Think about this for a moment. In the 1980s, making a mobile call felt futuristic, but your battery might die before the conversation ended. Today, your phone streams high-definition video, runs businesses, and connects to smart devices all around you. So what actually changed from 1G to 5G? And why are researchers already talking about 6G? Let's break down every mobile generation, clearly and simply. Quick context: the G just means generation. But each generation isn't just about speed. It represents a major upgrade in network technology, efficiency, and purpose. Every jump didn't just improve phones, it changed how we use them. 1G. The analog era. 1G arrived in the late 70s and early 80s. It was completely analog. Your voice traveled as raw radio signals, no encryption, no digital processing. That meant weak call quality, very poor security, huge devices. Short battery life, speeds were around 2.4 kbps, extremely slow by today's standards. There was also no global standard. Different countries built different systems. If you traveled abroad, your phone likely wouldn't work at all. Still, 1G proved something powerful. Mobile communication was possible. Going digital. In 1991, 2G changed everything. Networks switched from analog to digital transmission. Your voice was converted into data, compressed, secured, and transmitted more efficiently. Benefits included better call clarity, improved privacy, longer battery life, more users on the same network. This is when SIM cards were introduced, international roaming became realistic, and SMS texting was born. The first SMS ever sent simply said, "Merry Christmas." Speeds were still modest, around 9 to 14 kbps, but compared to 1G, it was a major leap. 2.5G and 2.75G, the internet arrives. Before full 3G launched, networks introduced GPRS and later EDGE. This era is often called 2.5G and 2.75G. For the first time, phones had an always-on internet connection. Speeds increased to 5100 kbps with GPRS, up to 384 kbps with EDGE web pages loaded slowly, but something important changed. Billing shifted from per-minute charges to per-megabyte data usage. That pricing model shaped the modern mobile internet economy. It wasn't fast, but it introduced the idea of mobile browsing. 3G, the smartphone foundation. 3G brought real mobile broadband. Initial speeds reached a few hundred kbps, later improving to several mbps with upgrades. For the first time, video calls became possible. Mobile websites became usable. App downloads felt practical. Then in 2007, smartphones exploded in popularity. The phone stopped being just a communication device. It became a portable computer. 3G laid the technical foundation for app ecosystems and mobile media. 4G, the app economy engine. Around 2009, 4G LTE launched. Speeds jumped to 100 mbps and beyond. Latency dropped significantly, but the biggest shift was architectural. 4G became fully IP-based, meaning everything, including voice calls, traveled as data packets. This allowed services like WhatsApp, FaceTime, Uber, Instagram, TikTok to operate smoothly at scale. 4G didn't just improve performance, it made mobile internet stable enough for entire industries to depend on it daily. 5G, built for scale. 5G introduced much higher speeds and extremely low latency. Peak speeds can reach up to 20 Gbps. Latency can drop close to 1 millisecond under ideal conditions. But here's the key insight: 5G isn't mainly about making your phone feel faster. It's designed for massive connectivity. It supports smart factories, autonomous vehicles, smart cities, large-scale IoT systems. It can handle up to 1 million devices per square kilometer. It also uses higher frequency spectrum bands, which carry huge amounts of data, but over shorter distances, increasing capacity in dense areas. 5G improves efficiency, reliability, and scalability. 6G, looking toward 2030. Researchers are already developing 6G, with potential rollout around 2030. Early goals include even higher speeds, near real-time responsiveness, greater device density, AI integrated directly into network systems. The idea isn't just faster data, but smarter networks. However, 6G is still in research stages, and final standards are years away. Common misunderstandings. A higher G doesn't automatically mean better coverage. Post-peak speeds are not everyday speeds. A 5G doesn't instantly replace 4G, they work together. Each generation takes years to mature fully. Quick recap. 1G made mobile calls possible. 2G made them digital and global. 2.5G introduced mobile internet. 3G enabled smartphones. 4G powered the app economy. 5G supports automation and massive connectivity. 6G aims to integrate intelligence deeper into networks. In just a few decades, we moved from analog voice calls to intelligent global infrastructure. If this explanation made mobile generations clearer for you, consider liking the video. And if you enjoy simple, practical tech breakdowns, subscribe for more.